Angle properties of circles. Here we've got a diagram with 3 points on the circumference, P, Q and R. The arc PQ refers to the minor arc, that's this short arc here. And the arc PRQ refers to the major arc, that's the larger arc that goes all the way around through R. This angle here is called angle POQ, and we can say that angle POQ intercepts the arc PQ. And we can also say that the arc PQ subtends the angle POQ. This is called the central angle. The vertex is at the centre and the radii are the sides. The measure of a central angle and the arc it intercepts are equal. So the measure of angle POQ here is equal to the measure of the arc PQ here. If we join R to P and Q, then this angle here is called the inscribed angle. Its vertex is on the circle and the chords are the sides. Theorem: the measure of an angle inscribed in a circle is half the measure of the arc subtending it. Let's look at a proof. On the diagram, we have the line PA and the line AR. This angle here, PAR, is the inscribed angle, and this arc here, PR, is the arc subtending it. Let's turn this into an isosceles triangle made up of 2 radii. So this angle here is also theta. Now this angle here is going to be 180 minus 2 theta, because the angles in a triangle add up to 180. And then this angle here is going to be 180 minus 180 minus 2 theta, because these 2 angles here lie on a straight line, so they add up to 180. This simplifies to 180 minus 180 plus 2 theta, which is 2 theta. This means that the measure of the arc PR is also 2 theta. So the measure of angle PAR, which was theta, is half of the measure of arc PR, which is 2 theta. Example: if the measure of the arc RP is 70 degrees, what will be the measure of the angle RAP? Let's draw in the angle RAP here. The measure of angle RAP is half the measure of the arc RP, which is half of 70, which is 35. Example: if the measure of the angle ROP is 60 degrees, what is the measure of the angle RAP? So on the diagram, we're trying to find this angle here. It's going to be half of the measure of the arc RP. And the arc RP is going to be the same as the angle at the centre, which is 60 degrees. So the measure of the arc RP is 60 degrees, and the measure of the angle RAP is half of this, which is 30 degrees. Example: in this circle, find the size of angle X. Let's draw in this angle here. This angle here is equal to the measure of this arc, which is twice the measure of angle ARP. So it's twice 36, so it's 72 degrees. Now let's turn this into a triangle. These 2 angles are equal because this large triangle is isosceles. These 2 angles are equal because this smaller triangle is isosceles. And that means that this angle here must also be equal to X. And now we've got a quadrilateral OARP. So this must add up to 360 degrees. We need to find this angle here around O so that we can add it up with X, 36 and X. This angle is 360 minus 72, which is 288. So we can do 288 plus 36 plus X equals 360. So 324 plus 2X equals 360, and X equals 18 degrees. The angle inscribed in the semicircle is a right angle. Example: in circle O, AB is the diameter. Find the size of angle X. Let's start by filling in this missing angle here. This is angle BAD, and it's equal to 180 minus 110, which is 70. Now, to find X, we really need to find this angle here. And to find this angle, it's the exterior angle of a triangle, so we can add together the opposite two interior angles. We know that this angle here is a right angle, so we need to add together 70 and 90. So angle DBC is 160. Now we have an isosceles triangle, so this angle here is also x. So x plus 160 equals 180. So x equals 10 degrees. Cyclic quadrilaterals. A cyclic quadrilateral is a quadrilateral whose vertices all touch the circumference of a circle, like in this example here. If this angle here is theta, then the measure of this arc here is 2 theta, which means that the measure of the remaining arc is 360 minus 2 theta. But then that means that this angle here is half of that, so 180 minus theta. So we can see that the opposite angles in a cyclic quadrilateral add up to 180 degrees. Example. Calculate the values of the unknowns. X is 180 minus 100, which is 80, because x and 100 are opposite angles, so they add up to 180. And y is 180 minus 140, which is 40. Example. In circle O, the measure of the angle COE is 68 degrees. Find the measure of the angle CAE and the measure of the angle CDE. So we want to find these two angles here. First of all, let's draw in this arc here. The measure of this arc is equal to the angle at the centre, so it's 68 degrees. The measure of the angle inscribed at the circumference is half of this, so it's 34 degrees. Then ACDE is a cyclic quadrilateral, and A and D are opposite, so they add up to 180. So the size of angle CDE is equal to 180 minus 34, which is 146. Arcs, sectors, and segments. This is a sector. It's a region bounded by 2 radii and an arc. This is a segment. It's a region bounded by a chord and an arc. Let's suppose that we wanted to find the length of this arc, L. Let's start with the whole circumference, which is 2 times pi times r. Then the fraction that we want to find is equal to theta over 360. So the length L is equal to theta over 360 times 2 pi r, which simplifies to pi r theta over 180. The perimeter of this sector is equal to the arc length L plus r, so it's pi r theta over 180 plus 2r. Then if we wanted to find the area of this sector, we could start with the area of the whole circle, which is pi r squared, and then the fraction that we want is theta over 360. So the area of the sector is theta over 360 times pi r squared, which simplifies to pi r squared theta over 360. The area of this segment is equal to the area of the sector, which is pi r squared theta over 360, minus the area of this triangle, which is a half r squared sine theta. The perimeter of the segment is equal to the arc length plus the chord length. Let's find the chord length. Here's the diagram. Let's divide this triangle in half. Then this angle is theta over 2. These two sides are both r, and this length here is x. This is the length we're trying to find. We can use trigonometry to get that sine of theta over 2 equals opposite over hypotenuse, which is x over r. So x equals r sine theta over 2. So the chord length is 2x, which is 2r sine theta over 2. And the perimeter of the segment is pi r theta over 180 plus 2r sine theta over 2. Example. Find the area of the sector and the length of the arc. Here are the formulae. The length of the arc is pi times r times theta over 180, which is pi times 5 times 45 over 180, which is 5 pi over 4 centimetres. The area of the sector is pi r squared theta over 360, which is pi times 5 squared times 45 over 360, which is 25 pi over 8. Example. Calculate the perimeter and the area of the following figure, where the curves are arcs of a circle with a common centre at O. Here are the formulae. For the perimeter, we need to find this arc length, plus 10, plus 5, plus this arc length, plus 5. So it's pi times 10 times 90 over 180, plus 10, plus 5, plus pi times 5 times 90 over 180, plus 5, which is 5 pi plus 15 plus 2.5 pi plus 5, which is 7.5 pi plus 20. And for the area, we want to find the area of this sector plus the area of this sector, which is pi times 10 squared times 90 over 360, plus pi times 5 squared times 90 over 360, which is 25 pi plus 25 pi over 4, which is 125 pi over 4. To summarise, the line from the centre perpendicular to a chord bisects the chord. Equal chords are equidistant from the centre. Every diameter is a chord. A tangent meets the radius at 90 degrees. If two tangents are drawn to a circle from an external point, then the tangents are equal in length. The measure of a central angle and the arc it intercepts are equal. The measure of an angle inscribed in a circle is half the measure of the arc subtending it. A cyclic quadrilateral is a quadrilateral whose vertices all touch the circumference of a circle. Opposite angles of a cyclic quadrilateral add up to 180 degrees. A sector is a region bounded by two radii and an arc. A segment is a region bounded by a chord and an arc. For a sector or segment with central angle θ and radius r, the length of the arc is L equals pi r θ over 180. The area A of the sector is A equals pi r squared θ over 360. The area A of the segment is A equals pi r squared θ over 360 minus r squared sine θ over 2. Review questions part 1. A, B, C and D are points on the circumference of a circle. Find the size of angle ACD. Pause the video whilst you work it out. Here's the answer. It's 54 degrees. Part 2. A, B and C are points on the circumference of circle O. The measure of angle OCB is 22 degrees. The measure of angle OAB is 67 degrees. Find the size of angle ABC. Pause the video whilst you work it out. Here's the answer. If we extend this line, then the measure of this arc is 134, because it's twice as big as 67. If we extend this line, then the measure of this arc is 44, because it's twice as big as 22. So the measure of this arc is 90. So this angle is 90. So this angle is 90. So the measure of this arc is 90. So x is half of 90, which is 45. Part 3. A, B and C are points on the circumference of circle O. The measure of angle ACB is 31. Find the size of angle ABO. Pause the video whilst you work it out. Here's the answer. This angle is 62 because it's twice as big as 31. So x is 59 by using the fact that this is an isosceles triangle. Part 4. A, B and C are points on the circumference of circle O. The measure of the arc ACB is 310. Find the size of angle ACB. Pause the video whilst you work it out. Here's the answer. The measure of the arc ACB all the way around here is 310. So this missing bit here is 50 degrees, which means that x is half of 50, which is 25 degrees. Part 5. A, B and C are points on the circumference of circle O. The measure of angle ABO is 62 degrees. Find the size of angle ACB. Pause the video whilst you work it out. Here's the answer. Use the fact that this is an isosceles triangle to get that this angle here at the centre is 56. So the measure of this arc is 56, and x is half of 56, which is 28 degrees. Part 6. A, B, C and D are points on the circumference of circle O. The measure of angle BAD is 70 degrees. Work out the value of x and y. Pause the video whilst you work it out. Here's the answer. X is 140, and y is 110. Area of triangles and parallelograms. The area of a triangle is half the product of two sides times the sine of the included angle. Let's look at a proof of this. We can draw the diagram like this. Here are the two sides, A and B, and here's the included angle theta. The height of this triangle is labelled as h. The area we know is half times base times height, so half times b times h. So what we need to do is rewrite h in terms of a, b and theta. From trigonometry, we can write that sine of theta is the opposite over the hypotenuse, so h over a. So h is a times sine theta. So this means that we can rewrite the area as a half times b times a sine theta. So it's a half times the product of the two sides times the sine of the included angle. Heron's formula. The area of a triangle with sides A, B and C is given by the formula A equals the square root of S times S minus A times S minus B times S minus C, where S equals A plus B plus C over 2. Here's an example. First of all, to work out the area of this triangle, we need to find S, which is A plus B plus C over 2, or 7 plus 8 plus 9 over 2, which is 12. Then we can use the formula A is the square root of S times S minus A times S minus B times S minus C to get that the area is the square root of 12 times 12 minus 7 times 12 minus 8 times 12 minus 9, which is the square root of 12 times 5 times 4 times 3, which is 26.83 centimeters squared. Example. In triangle PQR, QT and RZ are altitudes of the triangle, and PQ is 6, PR is 5, and RZ is 4. Find the length of QT. So we want to find the length of this line here. To do this, let's find the area of the triangle in two different ways. First of all, we can use this as the base, which means that this is the height. So the area will be half times 6 times 4. Or we could use this as the base, and then this would be the height. So the area will be a half times 5 times the length of QT. So this means that a half times 6 times 4 is equal to a half times 5 times QT. So QT is 24 over 5 centimeters. Now let's have a look at parallelograms. A parallelogram is made up of two triangles, like this. You can divide it in half down the middle to make a triangle here and a triangle here. The area of a triangle we know is a half times base times height. So the area of a parallelogram is 2 times a half times base times height, because both the two triangles are identical. So the area of the parallelogram is base times perpendicular height. Example. In the parallelogram ABCD, AB is 2, AD is 3, and the measure of angle B is 60 degrees. Find the length of the altitude from A to DC. Here's DC, so we're trying to find this length here. Let's call it H. We can label this side as 2 because it's the same as this side, and we can label the base here as 3 because it's the same as AD. There are two ways that we could find the area of this parallelogram. We can use the fact that the parallelogram is made up of two triangles and use the formula a half AB sine theta, or we could use the formula that the area of a parallelogram is the base times the perpendicular height. Let's do both of those and make them equal to each other. So we'll start with the fact that the area of the parallelogram is 2 times the area of a triangle. If we take this to be the triangle, ABC, then the area of this is going to be a half times 2 times 3 times sine 60. So the area of the parallelogram is 2 times a half times 2 times 3 times sine 60. And now if we use the fact that the parallelogram is base times height, then the area of the parallelogram is 2 for DC times h. So we can say that 2 times 3 times sine 60 is equal to 2h. So h is 2.60 centimeters. Now we're going to have a look at surface area and volume of prisms. A prism looks like this. It's got the same cross section all the way down. This is the lower base, this is the upper base, and this is one of the lateral faces. The union of the lateral faces of a prism is the lateral surface. The union of its lateral faces and its two bases is the total surface. The perpendicular distance between the upper and lower bases is the altitude. This is a triangular prism, this is a pentagonal prism, and this is a hexagonal prism. They're named based on their bases, and in each case, the cross-sectional area is the same all the way down the prism. This is the altitude, h. This is one of the edges. The total surface area of the prism is equal to the lateral surface area, so that's the area of these faces here, all the way around the middle, plus 2 times the area of the base, so that's once for the top base here, the upper base, and once for the lower base. This is the lateral surface area, and it's found by multiplying the base times the height, plus this base times the height, plus the next base times the height, plus the next base times the height, and so on. And if you factorize out h, then this works out to be the perimeter of the base multiplied by the height. So AL equals P times h, and AB is the area of the base. For the volume of a prism, you want to find the area of the base and then multiply it by the height. So V equals AB times h. For a cylinder with altitude h and radius r, we can use the same formulas: AL equals PH, AT equals AL plus 2AB, and V equals ABH. In this case, the lateral surface, which is the perimeter times the height, is going to be the circumference of the base times the height, which is 2 pi r times h. So the total surface area will be 2 pi r times h plus 2 times the area of the base, and the area of the base is the area of a circle, which is pi r squared. The volume is going to be the area of the base, pi r squared, multiplied by h. Example, find AL, AT, and V for this cuboid. AL is PH, AT is AL plus 2AB, and V is ABH. The perimeter of this cuboid is 5 plus 4 plus 5 plus 4, or 2 times 5 plus 4, which is 18 centimeters. So AL is 18 times 8, because 8 is the height, which is 144 centimeters squared. AT is 144 plus 2 times the area of the base, and the area of the base is 5 times 4, which is 20. So it's 144 plus 2 times 20, which is 184 centimeters squared. And the volume is the area of the base, 20, times the height, h, which is 20 times 8, which is 160 centimeters cubed. Example, find AL, AT, and V for this cylinder. The lateral surface area is 2 pi r times h, which in this case is 2 times pi times 3 for the radius times 6 for the height, which is 36 pi centimeters squared. The total surface area is AL plus 2AB, and in this case the area of the base is pi times 3 squared, so it's 36 pi plus 2 times pi times 3 squared, which is 36 pi plus 18 pi, which is 54 pi centimeters squared. And the volume is pi times 3 squared for the area of the base multiplied by the height, which is 6. So pi times 3 squared times 6, which is 54 pi centimeters cubed. Example, find AL, AT, and V for this prism. AL is the perimeter times the height, so we need to find the length of this side here so that we can find the perimeter of this triangle. We can use Pythagoras' theorem, a squared plus b squared equals c squared. So 5 squared plus 12 squared equals c squared. So 25 plus 144 equals c squared. 169 equals c squared. So 13 equals c. So the perimeter is 5 plus 12 plus 13, which is 30 centimeters. Now we can find AL is 30 times the height, which is 15. 30 times 15, which is 450 centimeters squared. Now we can find the total surface area, AT, which is AL plus 2 times the area of the base. The area of the base is the area of this triangle, which is a half times 5 times 12, which is 30 centimeters squared. So the total surface area is 450 for the lateral surface area plus 2 times 30, which is 510 centimeters squared. The volume is the area of the base multiplied by the height, so 30 for the area of this triangle multiplied by 15, which is 450 centimeters cubed. Example, find AL, AT and V for this prism. To find AL and AT, we need the perimeter of the base. So we need to work out the length of this side here. Let's extend it to create a triangle, and then we can use the fact that this is 12 because it's 20 minus 8, and this is 5 because it's 10 minus 5, and we can use Pythagoras. So 12 squared plus 5 squared equals c squared, 144 plus 25 equals c squared, 169 equals c squared, so 13 equals c. So this length here is 13. Now we can find the perimeter of the base. It's 10 plus 20 plus 5 plus 13 plus 8, which is 51 centimeters. The area of this base is the area of the whole rectangle minus this missing triangle here. So it's 20 times 10 for the whole rectangle minus a half times 12 times 5, which is 200 minus 30, which is 170 centimeters. So AL is perimeter times h, which is 51 times 15, which is 765 centimeters squared. AT is AL plus 2AB, which is 765 plus 2 times 170, which is 1105 centimeters squared. And the volume is AB times h, which is 170 times 15, which is 2,550 centimeters cubed. Example, a water tank is a right cylinder with radius 40 centimeters and depth 150 centimeters. It is filled at the rate of 0.2 liters per second, where 1 liter is 1,000 centimeters cubed. Does it take longer than 1 hour to fill the tank? Here's a diagram of the cylinder. Its radius is 40 and its height is 150. We're interested in the amount of water inside the tank, so we want to find the volume of this cylinder. The volume is pi r squared times h, which is pi times 40 squared times 150, which is 753,982.24 centimeters cubed, which is approximately 753.98 liters. Now let's have a look at how much water we can get into the tank in 1 hour. 1 hour is 60 minutes, which is 3,600 seconds. Each second we can fill 0.2 liters, so 3,600 times 0.2 is 720 liters altogether. So yes, it does take more than 1 hour because we actually need to fill more than 720 liters. Example. A circular hole of radius 2 centimeters is drilled through the center of a solid right circular cylinder with base radius 6 and altitude 8. Find the total surface area and volume of the resulting solid figure. We need to use the fact that the lateral surface area is equal to the lateral surface area of the large cylinder, so 2 pi RH, plus the lateral surface area of the smaller cylinder, 2 pi RH, which is 2 times pi times 6 times 8, plus 2 times pi times 2 times 8, which is 128 pi centimeters squared. So the total surface area is the lateral surface area plus 2 times the area of the base. The area of the base is the area of the larger circle minus the area of the smaller circle, which is pi times 6 squared minus pi times 2 squared, which is 32 pi. So the total surface area is 128 pi plus 2 times 32 pi, which is 128 pi plus 64 pi, which is 192 pi centimeters squared. The volume is the area of the base times the height, which is 32 pi times 8, which is 256 pi centimeters cubed. To summarize, if the angle between A and B is theta, then the area A of the triangle is A equals a half AB sine theta. If the three sides of a triangle are A, B and C, then the area can be calculated as follows. A equals the square root of S times S minus A times S minus B times S minus C, where S equals A plus B plus C over 2. This is Heron's formula. The area of a parallelogram is the product of the base and the height, A equals BH. The area of a parallelogram is the product of the two adjacent sides and the sine of the included angle, area equals AB sine theta. A prism is a 3D shape whose cross-section is the same throughout the height. The volume of a prism is calculated as follows: V equals the area of the cross-section, or the area of the base, multiplied by the vertical height. The lateral surface area of a prism is AL equals PH, which is the perimeter times the height. The total surface area of a prism is AT equals AL plus 2AB, where AB is the area of the base. If R is the radius and H is the height of a right cylinder, then AL equals 2 pi RH, AT equals 2 pi RH plus 2 pi R.